The most expensive part of the example I just showed is the nested loops. It results in a multiplicative explosion of unnecessary and inefficient activity. The answer then is pretty straightforward. A series of queries to retrieve the related objects, which have maps constructed based on their results, and then those maps are referenced to update customer reward balances. In the Order Manager class, the run method is the main branching point for the order trigger logic. In fact, in the order trigger itself, all there is to be found is the creation of a new instance of the Order Manager class, and a call to its run method. Each trigger in the example code is structured the same way. Inside the run method, there are pre-processing methods, followed by a main loop, followed by post-processing method calls. The idea as this code exists within the example material here is that each trigger is written the same way. This is done here for multiple reasons, and you'll find is often done in the real world too. It is easier for developers to understand and work on in the long term, of course, and also, the trigger itself is executing the same way every time anyway. So why not have a consistent way for code to handle it? Inside of the pre-processing methods, there are two method calls to manage related collections and manage reward lookup. These handle the executing of SOQL queries and construction of maps that are needed for reference. In manage related collections, queries are done to get existing reward balance records that are associated with the customer contact IDs tied to the orders. With the reward balance query results, a map using the customer contact ID is constructed. The next method that puts together reference maps in the pre-processing phase is manage reward lookup. This method retrieves reward lookups, maps based on product ID, and retrieves order products, which then uses the reward lookup map to map how many reward points are associated with a given order ID. With pre-processing complete, the main loop through the records of the trigger proceeds. The method that concerns the requirement is the check_reward method. Check_reward then leads to update reward balance after passing the criteria for this conditional, which requires that the order has to have an ID, and that ID must be contained within the order ID to reward points map. Finally, this is the method comparable to the one shown before with the 4 nested loops. But this time, instead, all that has to be done is initialize a new reward balance where needed, or add new reward balance transactions for when a reward balance for a given customer already exists. Throughout this logic, the only thing that's needed to know what to update is which keys tie back to which maps, and those maps provide the answers needed. It's a direct reference to a key value pair, instead of a scan through lists. I've included a lot of little details to consider in this example material, so I recommend spending some time with it and making your own changes. While this applies the techniques mentioned in the previous clips, it does so in a way that is much closer to a real-world application. That said, there are many more things to consider about the scenario here, more than could possibly be covered in this module alone. However, you have zero time pressure the way you would in the real world. You're free to experiment with this example code as much as you'd like. A different test in Order Manager test, update reward balances bulk, performs the same setup from before. 400 orders, 4 reward balances, 400 order products, and 4 reward lookups. But this time, because there are no nested loops, there are not 1.28 million operations to go through. In the next clip, we'll take a closer look at examining Apex performance and collecting metrics for knowing how close code is to governor limit violations.